Hello and welcome back to Kerbal Space Programming. This episode is going to be a little bit different from the things we have run before because Jebediah has built a very special test craft. Jebediah has been a little unimpressed with the way that we've been writing scripts, saying things like lock throttle to 1 and to 3.5. That's no way to fly, he says, and after all, Jebediah is the expert in manual Kerbal rocket and spaceplane flying. And but his suggestion is instead that you have a target, right? You're trying to go to a particular height, or you're trying to get to a particular apoapse, and you know where you are currently. And really, instead of saying, well, we're just going to put the throttle at a fixed number, we should say, okay, if it's far away, well, we're going to throttle up a lot. And if it's really close by, then you only have to throttle a little. And so he has built this amazing test craft called Kerbal, and written a script to try and demonstrate his theory. Let's take a look at that. Alrighty, so let's take a look at the script that Jebediah has written. He set up a function called p-loop. This is going to be a proportional loop. It says, okay, we're going to take two arguments. We've got a target, and we've got what our current value is. And then all we're going to do is we're going to take the difference. We're going to say, okay, if we're trying to get to, say, 500 meters off the ground, and we're 200 meters off the ground, well then, we should return a big number. But if those numbers are exact, then it should be roughly 0. And then the last thing that he's added here is this p-scale value. Because if we look at how this would work, like let's say that we were going to say, set the throttle to p-loop, and we say that we're trying to get to 500 meters up and our current is 200 meters up. Well, if we just took the difference, 500 minus 200, well then we would try and set the throttle to 300, and that's not great. Instead, he's going to add a multiplier, and he set this p-scale value up here to 0.002. So that's going to go ahead and take 300 and instead multiply it by 0.002. I can type. And that is going to give us a different value. Let's check what that is, because I am not... that's not something I can do off the top of my head. 300 times 0.002. That will give us a thrust value of 0.6, which is much more reasonable because we're dealing with throttle values between 0 and 1. So if we're 300 meters away from our target, well then our throttle value should be roughly 0.6. But if we're really close, then, if we've got, say, 500 minus, 480, well, then we're still going to multiply that by our scale, 0.02. And what is that going to get us? Well, that's going to get us 20 times 0.002. Let's jump into a terminal and check that again. 20 times 0.002. Well, that gives us a very, very, very small amount of thrust indeed, because we are very close to the target where we want to be. So, having written this function, Jebediah's theory is, well, we should be able to just set our throttle based on our current altitude. So here's what he has written to test out this script. So we're first going to lock our steering to up, and we're going to lock our throttle to 0.2, and then we're going to stage, and we're going to wait until we get 500 meters off the ground. This is just going to slowly bring the Kerbal craft up to 500 meters. And now we're going to test our proportional function that we've just written. We're going to say we'll set a variable called auto throttle to 0, and we're going to lock the throttle to always grab the value from that variable. Okay? Then we're going to say until we're almost out of fuel, we're going to say set the auto throttle to p-loop 500 and our current altitude. So we're going to say we want to be at 500 and we're currently at whatever we're at. We're going to get that value. And then the last thing that he's going to do is he's going to do this max and min thing. Let me explain this real quick. We've got we're taking the maximum of two numbers. So if you take max of 100 and 200, well, you're going to get 200, right? Now we want to make sure that whatever we get back here is between 0 and 1. So what we're going to say is okay, so we've got some value that we got back. We want to make sure that we get the maximum of 0 and that value. So if the value is -1, well, that's fine. We'll just say our value is 0. And then we're also going to take the min to make sure that it's not greater than 1. So if we say that, and our value was 500, well then it's going to be 1. But as long as the value is in between these two numbers, then we'll get the value that we actually want. So we're saying a maximum of 0 and then a minimum of the current value and 1. So this will make sure that we get the value that we want from the loop, but that it won't go out of range of what we're able to throttle to. And I suppose we should probably put a little weight in there. 0, 1. There we go. So this is going to go ahead and call this proportional loop to make sure that our throttle is based on the difference between 500 and our current altitude. And then once we've run out of liquid fuel, we're going to lock the throttle to 0 and we'll stage, which will deploy the parachutes and bring this down to a soft landing. So Jebediah is very excited to test this off, and we're going to see exactly what it does. Let's jump over. Alrighty, Jebediah, are you ready? Script is loaded and will launch momentarily. Oh, there we go. And we are slowly bringing ourselves up. Jebediah, perhaps you should have stepped a little further away from your test craft, because this is looking a little dangerous. You can see those clouds out there. We're launching off the runway, by the way, because there is a small bug with the launch pad. I think when it's only partially upgraded, that occasionally the rockets will stick to the pad, and so I encountered some issues there. So we jumped over to the to the runway rather than the launch pad. All right, so now we've got up to 500, and you see our engine cut out, which makes sense, right? Because we are more than 500 off the ground, so our value that we get from that loop should be 0. And we can watch the throttle here. As we're further and further away, the throttle's going up, right? Because the difference is greater. And as we get closer to 500, we end up throttling all the way down and cutting off the engine. So what Jebediah has done, clever Jebediah, is actually written a hover script. Granted, not, the best hover script. There's an awful lot of variance here. We're kind of looping above and below the target. But the cool thing about this is that we are not having to manually set the throttle at all. We're just giving it the value of what we want our altitude to be, and then saying, yeah, okay, you go ahead and figure out the rest. So yes, we continue along watching our hover script go up and down as the engine valiantly tries to keep us somewhere close to that 500 meters. And this is something we'll be improving upon in the next several episodes, which I'm very excited about and should let us do a lot more cool automated stuff. But eventually we do run out of fuel, at which point we come in to land. And there we go, we have run out of fuel. But that is okay. Not run out of fuel. We had some reserve there, but we've gone ahead and deployed our parachutes, which means that this can come down for a soft landing. Hopefully, not right on top of Jebediah. Jeb, you really should be more careful about that runway, because let's see, how are we doing? There you are. Oh man, I'm getting we're losing some frames, but that's okay. And just bring this down very carefully. And touchdown of the first voyage of Kerbal. And look at Jebediah. He's so unenthused. Alright, well, it could have been a better test, Jebediah. I agree. Let's look at improving that. So in order to make some improvements for our next run, I've added a little bit to our proportional function test. First, we're going to switch to 0, and this is after we've gotten up to our altitude and we've set our auto throttle and that sort of stuff. We're going to switch to the archive. We're very close to the Space Center, so we're just going to go ahead and write out some information directly to the archive, and we're going to set the start time to time seconds. And this is a total seconds of the current time. So we're going to use that as a reference to say, okay, that's going to be 0 seconds since we started the test. And then if we call time seconds later, we can say, okay, well, we'll just subtract that and we'll say, okay, well, it was 1 second later or 2 seconds later or that sort of thing. Then inside our loop where we're doing our setting our auto throttle stuff, actually, I should probably throw this up here instead of before the wait. I'm going to use this log command. Now, what this is going to do is it's going to write a particular string of characters to a file. So I could say log hello to my log.txt or something like that. Instead, what we're going to do is we're going to take that time seconds and subtract our start time. So we're going to get the difference in time since we started our test, and we're going to add a comma. Then we're going to add the current altitude, and another comma, and then we're going to log out what our throttle value was. And we're going to log that to testflight.csv. CSV means comma separated value. It's a type of file format, and you end up with things like, 1, 2, 3, and then on the next line, 3, 4, 5, and that sort of thing. And it's just a way so that we can know, okay, well, the first value is this thing, and the second value is another thing, and the third value is another thing, and then this is another entry. So each time we go through this loop, we're going to be adding an entry to this testflight.csv file. And then, yeah, that's the only change that we had to make. So the next thing that I'm going to do is I'm going to open up that file, because I went through and ran this test again. So let's jump into testflight.csv. All right, oops, there we go. All right, so this is not super readable at the moment, but it would be very easy for us to write other scripts to parse. Let's go ahead and see if I can clean this up a little bit. There we go. That's a little bit better. And remember, the first thing that we logged out was the elapsed time, and then we logged out the current altitude, and then we logged out the throttle value. So as we see, when we began the test, our altitude was 501.3 meters off the ground, and this ran 0.02 seconds after we started, and our throttle was 0, which we expect, right? Because we were above the 500, so we didn't need to throttle anymore. We were already above, and we see we've still got the momentum from when we were initially rising. Yeah, and unfortunately the formatting is a little iffy, but we go up and up and up. If we're just tracking this column here, we go up and we can see we hit 560, and it looks like there we go. And now we're starting to decrease. So that was the top of our arc. And this is 4 seconds after we started our test, and the throttle's still at 0. We get down, we come back down, we start drifting down, and this is all stuff that we saw when we ran our test. And now we see here, we've gotten below 500, and as soon as we get to 499, then all of a sudden we actually have a throttle value. And our first throttle value is very, very, very tiny. It's 0.00024, which is not going to do much to slow us down. But as we see, as we get below that 500 target, well, the throttle in that right-hand column is going to go up and up and up. And we're getting down to 290, and we're throttling now at almost half, 0.4. And oh, look, we started to pick up again. So there we go. We bottomed out at like 286, about 13 seconds in, and we have our max throttle value here of something like 0.426. So just a little lower than half throttle by the time we get to the absolute bottom. So what I'm going to do now is actually take this information and throw it into a chart so we can look at it easier. Okay, so I've gone ahead and uploaded our testflight.csv file to Google Spreadsheets because, hey, it's free. And the cool thing about CSV files is that you can throw them into any sort of spreadsheet software. And now we can see kind of the data that we were looking at in its raw form. We have the throttle values and the elapsed time and the altitude. And if we scroll down, we see we've got a lot of different records. And as we dip below 500, we've got all those things. And we see this is 7,500 different data points, which is a lot for us to try and wrap our heads around. So before we do anything, I'm going to add up here some labels. I'm going to say this is time, and this is altitude, and then this is our throttle value. So now what I'm going to do is I'm going to select all of these, and I'm going to say insert chart. So we want to graph this stuff over time, and because there's a lot of data, it's going to lag a little bit. But we see, okay, it's giving us some suggestions. I'm going to say we're going to take time and altitude, and let's go to chart types. And we'll say use column A as the labels, because this is actually our x-axis on our chart. So if we do that, and now we can see that it's giving us our time and our altitude. And of course, this label will have to change. But there's one more thing just to make this easy for us to look at. I'm going to go ahead and cancel out of this. And let's get rid of this throttle column for the moment. We'll move that over there. And I'm just going to say target. And I'm going to enter 500. And let me just copy that. And then I'm going to select everything in this column and paste it in, because our target is always 500 regardless of where we are. And then let's try and chart this again, and of course let it spin and think, oh look, it's even giving us a sum of all of the values. That's great. So there we go. Okay, time, altitude, target. Let's jump over to chart types again and say use that first column as our label, because otherwise it's going to use these numbers because we don't care at what, in what order things were, we care what the time was. So here we go. We've got our altitude and our target. And I'm going to go ahead and just customize real quick. I'm going to say, take this to make this altitude over time. And let's see, should we do any more tweaking? We could, we could add, let me see, grid lines. Nah, I think we're good. Let's go ahead and insert that. And there we go. And let's go ahead and pop that over into its own sheet in our file. So there we go. Now we've got a nice, good chart, and we can visualize what happened with our craft's altitude over time. And our target was 500. So that was the goal that we were looking for. And when we started, we were just a little bit over. We got our altitude up to about 560, and then we started to come down. And we can see that our hover script is actually doing pretty good. It's increasing a little bit each time, but on average, it's staying, at least it's being consistent in its behavior. This is something that we're going to take a look at and use more when we go back and try and improve our hover script. But of course, we can't sit around all day writing random test ships. We actually have to do some of our contracts, and one of our contract is to test this Poodle engine in flight over Kerbal. We have to be flying, we have to be at Kerbal, we have to be over 5,000 meters and below 9,000 meters, and we have to make sure that we're traveling between 300 meters per second and 900 meters per second. So let's take a look at the thing we actually need to use. Okay, so here's our Poodle fuel engine. Let's pull that out, and oh boy, that is going to be big. But okay, we will make it work. And we have to activate this engine when all of these conditions are met. So we will have to stage to activate, but only once we've done that. So what else are we going to need? We're going to need probably a battery or two to make sure that this thing has power. So let's add 2 of those. Let's add some, you know what we're going to need? We're going to need this reflectron to make sure that we can communicate with the ship once it's on the launch pad. Only one of those, please. Put that on there. Let's add some parachutes. There you go, 2 of those. Wonderful. And let's make sure that those don't stage at the same time. And now all we have to do, so basically, if we had met these conditions, we could fire our staging event, and this would activate. It doesn't have to have fuel. We just need to stage it to meet the contract conditions. So now we just have to get this thing up to the correct staging conditions. And I'm going to add some solid rocket boosters to get us there. Where are those? There, engines. Okay. These solid, nope, not upside down. That's less of what I wanted. There we go. That's closer to what I wanted. And these are going to go really fast, and they should hopefully get us up there. Let's add some parachutes to these as well to make sure that we're able to recover this. Let's see, how much do we get from this contract? It doesn't say, but we are spending, let's see, 7,000 funds to try this out. Let's just make sure our staging is all set up. We'll go ahead and move the solid rocket boosters down. So we'll stage those to get us to the right altitude and right speed, and then we'll stage this engine, which won't actually do anything, and then finally we'll stage to try and recover the craft. So let's call this, let's see, Fool's Errand 1, and write a script to do this contract. Okay, so Poodle test script V00.1. Well, first, obviously, we have to stage. We've got to get those rockets going. Ooh, you know what we should do? We should lock the steering to heading 9090. So we'll lock our steering to up so we don't randomly spin out. We'll stage, and that will activate our solid boosters. And now we've got to wait until all of those conditions are true. So rather than just saying wait until, this and that and this, well, I suppose we could do that. But let's instead say set conditions to false. And we'll say until conditions. And then we'll loop in here. Let's put a wait, because whenever you have these loops, you want to make sure that you wait a little bit so this thing doesn't run over and over and over and slow down your machine. So we'll say if, now we've got to start writing all these conditions. So we'll say ship vertical speed is greater than 300, and let's put some parentheses up here, and then just do this. We'll say ship vertical speed is less than 900, right? Because those are the conditions. And our altitude is greater than 5,000. And let's clean this up a little bit. There we go. And our altitude is less than 9,000. And no more ands. And close that, and then here. So we've got a big if condition. And inside that if condition, we'll say conditions, let's say set conditions to true. So this loop will just go wait and wait and wait, and then it'll check all of these things, and if all of them match, then it will set conditions to true, which will break it out of the loop. Great, so then we know that we are ready to do our contract, so we can stage to activate that Poodle engine. Contract, yay! And now all we have to do is wait to actually recover the thing. We don't want to deploy the parachutes because we might be going way too fast. So let's say wait until the altitude radar is less than, I don't know, 600? Maybe? We'll have to see if that works. And then we'll stage again to deploy our parachutes. So, let's see, this should hopefully work. Let's put it on the launch pad and try it out. Alrighty, I've popped open our terminal. We will have to see if this works. But hopefully we should... Okay, there we go. We did fire the first thing. We've got this open in case we get some errors. We'll see, we are spinning around a little bit. Oh, and let's look at our contracts. Where's our... There we go. Alright. So as soon as we get to the right altitude, hopefully, then we should fire the engine and we will see what happens. Oh, there we go! We got our contract. Wonderful. Tested the Poodle engine. And now it's just a question of whether we can recover. We did get some science. We got some funds. We got more funds than it cost us to build this thing. So that's a net gain. Go ahead and delete that. Oh, and then we've got the science data from around the moon from the last episode. So now let's just see if this works. So what did we set it to? 500? 600? Oh, I love those clouds. Though they are moving rather fast. Oh my goodness. Look at how high up we've gone. Well, I suppose that's not. And the planet is rotating beneath us. Alrighty. And now we've just got to hope that we've got enough. Oh, Jebediah is still out there, ready to do more tests. And our surface speed is down, so as long as these parachutes deploy at all, though we may come crashing down on top of a building, please don't come crashing down on top of a building. I think we should be okay as long as these deploy. You are going to land right on the... Alright. There we go. This is going to land right on our contract building, which seems somehow fitting. Oh, nope. Now we're loading stuff. Okay. Well, we can close that up because that script is done. Oh, come on. Load, load, load. Stop dropping frames. Oh, boy. Are we going to collide with the dish? Are we going to land right on the dish? Let's see. Nope, I think we're probably... Well, let's warp down and see what... Oh, boy. Yep. Oh, boy. Oh. Yes. So we will have some work to do in the next episode. I will hope to see you then. Cheers.